we have ever experienced. There seems to be no immediate end in sight. Let's pray to the Omnipotent to see us through this difficult period. Let's pray for a minute, please. Thank you. Chief guest of the evening, Professor Dr. Rao Tatwati, moderator Mr. S.R. Nair, Program Committee Chair, past presidents, managing committee members, KMA members, students, and our invited distinguished guests, a warm good evening and a hearty welcome to each and every one of you to the session. As most of you know, KMA has been organizing evening lectures, innumerable number of programs every week, like evening lectures, StartCon sessions, panel discussions, women-specific sessions, digital marketing, CEO conclave, leadership sessions, memory lectures, MSME sessions, and very many other programs as well. If I'm not mistaken, our Mr. S.R. Nair, Program Committee Chair and StartCon Chair, himself organized about 19 lecture sessions and 11 StartCon sessions. And each and every session, he made sure getting the best of the best speakers from all over the world. StartCon was his brainchild, and bringing the successful proprietors of startup companies and having an effective discussion. Each and every program is outstanding in terms of quality of the speakers and most relevant topics. Congratulations and a big thank you to you, Mr. S.R. Nair. Today, we are going to experience the 20th session in the Leadership Talk series. The World Health Organization has said air pollution is the greatest environmental risk to health. As the world suffers through a respiratory pandemic, the need to breathe clean air has never been more apparent. But with the World Health Organization estimating that 9 out of every 10 of us live in zones where the air exceeds guidelines limits of pollutants, breathable air is become a rarity. Air pollution contributes to the death of an estimated 7 million people worldwide annually, far exceeding the amount of death expected from COVID-19 this year. Yet, as a protracted public health emergency, it is awfully underreported. As per the Quality Air Index report, Delhi's air quality continues to be very poor. Noida's AQI severe at 497. As per the survey, Delhi is the most highly polluted state in India, and Kerala is the least polluted state. This is the only a little relief for us, but we know our conditions in terms of garbage, wage, etc. Today, to talk about the topic, changing paradigms of air pollution, we are indeed privileged and honored to have a scientist and technologist, the recipient of many national and international fellowship and awards, Professor Dr. Rao Tatwati, Director R&D at GVP SIRC, Distinguished Professor, GVP College of Engineering. To introduce this renowned speaker and to moderate this session, I proudly invite our one and only Mr. S.R. Nair, Program Committee Chair, Director, Mentor Guru, Professional Service Private Limited, serial entrepreneur and author. Over to you, Mr. S.R. Nair.
Thank you, Nirmala. I'm audible, right, Nirmala?
Yes, sir.
Yeah, thank you. I would introduce Professor Tatwati, and then we will give the podium to him to do the presentation. I understand that, okay, he has fairly 40-45 minutes worth of presentation to do. So post which, time permits, we will do the question and answer sessions. And because, it is important that we hear him, because all that we are hearing is very, very important for our life and living. Okay, so let me introduce Professor Tatwati to you. Okay. And let me also tell you that, okay, if you really wanted to introduce Professor Rao Tatwati, it may take about 30-35 minutes, even if it is abridged. So I have the abridged version to come to introduce you in about 2 to 3 minutes time. Okay. So Professor Rao, if I have missed something, and I'm just in advance, I'm seeking a mail from you, because, okay, right. Okay. Now, Professor Dr. Rao Tatwati possesses an outstanding academic and research career at some of the best institutions in the world. Dr. Tatwati had his first master's degree in marine sciences from Andhra University. Later, he joined IIT Madras for doing master's again in ocean engineering before moving to Canada to do his PhD. Okay. After completing his doctoral thesis, Dr. Rao was invited to join DRDO, Defense Research and Development Organization, where he had the opportunity to work on some of the highly classified areas related to naval surveillance. After a long stint with NPOL, Naval Physical Oceanography Laboratory in Kochi, Dr. Tattavarti opted for voluntary retirement as a director grade scientist. He then moved to academics as a senior professor and director of research and development at VIT, Vellore Institute of Technology, one of the finest of private universities in engineering and technology available in the country. Okay. From Vellore, he moved to Vizag, where he joined, that is his native place. He joined Gayatri Vidya Parishad Academic Institution as a senior professor and director, research and consulting. Okay. He was appointed the regional director of the National Maritime Foundation between 2013 and 2015. Dr. Rao pursues his academic interests even today. He also is a founder and managing partner of CATS Castle Advanced Technologies and Systems. He was involved in the development of novel environmental monitoring system for air quality monitoring. With this short brief, let me hand over the podium to Professor Rao Tattavarti. Let's hear him out. It's a matter of great importance, not only science, but also something we all need to understand for a finer living, for a quality living. Professor, all yours. Please go ahead. Prajit, please help him to get please give him the rights to do the presentations as well. Thank you.
Thank you, Mr. Nair, sir. Am I audible?
Indeed, sir. Indeed. Go ahead.
Yes. Thank you, ma'am. And I would like to place on record my profound gratitude to KMA for inviting me to this August gathering. And again, special thanks to Admiral Madhusudanan for making this possible. What I have planned to do is as follows. I had a chat with Shri Nair when a couple of days back, and I was sharing the title of my talk. I got a bit worried whether this August gathering will be the right place for scientists and technologists like me to talk about. Nevertheless, I thought I should make an attempt. So please bear with me if I'm not up to your expectations. I'll try to do whatever good job I can. I would be taking about 40-45 minutes, as Mr. Nair has remarked. The topic I'm going to discuss with you is changing paradigms of air pollution. Now, when we talk about paradigms, one would be compelled to talk about Thomas Kuhn. Thomas Kuhn was an American scientist and a physicist. In 1962, is my
it is audible. It is visible.
Yeah, good. Thomas Kuhn is an American physicist and was an American physicist and a scientist. In 1962, he has come up with a rather spectacular theory, a book rather, which is titled as The Structures of Scientific Revolutions. This was against the background of Newtonian physics, when Newton and his school of thought, which was practiced by most of the scientists and researchers all over the world, deemed that everything in physics was done and dusted. All the laws of motions, everything was explained by Newton. And that was when in 30s, Einstein comes up with earth-shattering theory, and he talks about relativity, special relativity, general relativity, etc., etc. So Thomas Kuhn was worried about how do people come up with these paradigm shifts. Just to bear with me for the benefit of everyone, paradigm is a sort of framework. The framework shift, how does this happen? So this leads to a rather curious questions. So I thought I will spend a minute or two about this paradigm shifts. Thomas Kuhn took one of those caricatures which from a German weekly humor and satire magazine called Fliegende Blätter, which basically means flying leaves or flying pages or loose sheets in a general translation. This is the image which you see. It's an optical illusion. Depending on your perception, you either see a rabbit or a duck.
That's right.
At the first instance. So once you see that, this is where in science also perception plays a very vital role. It's a major motivational driver for people to come up with new theories. So people who have seen the duck will start talking about the duck, its characteristics and all. People who have seen the rabbit will talk about the rabbit and its shape, size, how beautiful or how ugly it looks. So this was the basis for Thomas Kuhn to start talking about paradigm shifts. And both are right. Both the perceptions are right. So it also depends on your environment and your background to come up with a specific paradigm. So against this background, I thought I will talk about pollution. Now, everybody knows about pollution. So I thought I've taken the liberty of putting a 2-minute video, which I've basically extracted from National Geographic. Kindly bear with me, and this is a very generic video which talks about climate change and the related stuff. Here it goes.
Human activities, from pollution to overpopulation, are driving up the Earth's temperature and fundamentally changing the world around us.
Yes, sir.
Okay.
The main cause is a phenomenon known as the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's light in, but keep some of the heat from escaping, like the glass walls of a greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than 1/3 since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. Ice sheets, such as Greenland and Antarctica, are melting. The extra water that was once held in glaciers causes sea levels to rise and spills out of the oceans, flooding coastal regions. Warmer temperatures also make weather more extreme. This means not only more intense major storms, floods, and heavy snowfall, but also longer and more frequent droughts. These changes in weather pose challenges. Growing crops becomes more difficult. The areas where plants and animals can live shift, and water supplies are diminished. In addition to creating new agricultural challenges, climate change can directly affect people's physical health. In urban areas, the warmer atmosphere creates an environment that traps and increases the amount of smog. This is because smog contains ozone particles, which increase rapidly at higher temperatures. Exposure to higher levels of smog can cause health problems such as asthma, heart disease, and lung cancer. While the rapid rate of climate change is caused by humans, humans are also the ones who can combat it. If we work to replace fossil fuels with renewable energy sources like solar and wind, which don't produce greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change.
Well, that's an introductory video which talks about climate change and what are the effects, what is the cause, how the temperature has increased over the few hundreds of years back. But how do we know, if one asks the questions, how do we know that climate change really is happening? This has been possible by looking at ice core samples, either from the glaciers or core samples taken from the oceans, where it's possible to make a dating based on the core analysis and characteristics. So based on that dating from both ice cores from glaciers as well as the ocean bottom cores, scientists have come up with remarkable results that over so many hundreds of thousands of years, there's not much of change except from 1950 onwards, where there's a significant increase in the level of temperature, terrestrial temperature. So what does that reflect and what does that manifest as in today's parlance is forest fires, which have been noticing all over the world, melting of glaciers, which is quite common in the news, and most of us have seen this. Droughts in certain places, unseasonal heavy rains. Kerala is a good example now. Kerala and Tamil Nadu, and then floods. Of course, we either have both the extreme, either the floods or the drought, and India is affected by these extreme events. So all over the world, this is the scenario which are basically the effects of climate change, forest fires, areas turning arid, drought, and then extreme weather conditions like super cyclones, severe cyclones, whatnot. So all this gives rise to something like this, which we are now noticing in Kerala, New Delhi. This is a picture from New Delhi. So the smog and the fog and the pollution is so much, the visibility is extremely restricted. So with this as the background, what happens to us? Lancet has come out, it's one of the reputed medical magazines, has come out with a study based on significant research by international group of scientists, which talks about 9 million, which talks about the statistics that 9 million deaths worldwide occur every year. Out of this 9 million, India accounts for about 2.5 million. That is 25 lakh people die every year in India due to pollution-related ailments. In China, it is 1.6. Now, these figures are debatable. I'll come a bit about why I thought I should speak about the paradigm shifts in our thinking and in our perceptions. These figures are debatable, but by and large, we have enough. And Nirmala ma'am in her introductory remarks were talking about 9 out of 10 people do not breathe safe air. It's actually 9.2. 92% of the worldwide do not breathe safe air. That's a remarkable statistics, and it reflects on our health and our sustenance. I have poured through some of the PubMed, that is medical journals, and there is extreme evidence which suggests that apart from outdoors pollution, indoor air pollution, especially in countries like India and China, where for a very large time, not so long ago, people were using coal as a fuel instead of a CNG gas or LPG gas. So indoor air pollution accounts for 4.3 million deaths worldwide. Out of this 4.3 million, that is 43 lakh deaths just due to indoor air pollution. You don't have to step outside, you sit in your home and you will be affected by pollution. 22% are related to cardiovascular or respiratory diseases. About 6% are related to respiratory diseases, lung cancer, 12% pneumonia, and cardiovascular mortality accounts for about 34%, and CHD accounts for 26%. So this is a basic statistics which has come out of journals after long years of research and verified and vetted by WHO. So this is a remarkable statistic, which is one of the effects of climate change. Now, you don't have to believe the degree or the quantum of climate change based on the statistics, but nevertheless, there is ample evidence which suggests that yes, climate change results in mortalities. So against this background, this is the current scenario which is happening all over the world. We have recently witnessed COP26, I think, where a conference of all parties, which are basically governments all over the world, sat together and they discussed and they thought this is the gathering storm. The temperature keeps on rising. So how do we keep a stop to this rise in temperatures? So they said we need to adapt to climate change in a post-pandemic world. This is again based on the background. The background is COVID pandemic for after 2 years. So they have come up with environmental United Nations, WHO, and all other organizations and countries worldwide. So they have come up with a report saying Adaptation Gap Report 2021. So this is one of the debatable countries keep fighting about. So I would like to stress on this and then talk about this paradigm change. All of us, this is one of the slides which has flashed around all over the world saying that these are the annual carbon dioxide emissions, especially from burning of fossil fuels for energy as well as construction, infrastructure construction, that is cement production. But the land use change is not included. So look at these staggering statistics. If you are looking at the 2020 year, that is last year, China accounts for about 10 billion tons of carbon dioxide emission. Next is the United States, and India is not far behind. So this is a staggering statistics, and then all the Western countries, developed countries, started talking about our charge. China is one of the maximum polluters, so China should pay for most of the, how to mitigate the pollution. Or rather, India is also, if you are looking at the gross data, India is also rising. So India also should be responsible for mitigation of these carbon dioxide emissions. So this is the debating point. This is the point where I beg to differ. So I thought I will take a paradigm shift in the attitude in believing the statistics. So what I said, the reason for that is, if you believe in the statistic of major polluters in the world, then what happens is the planning, the finances, the implementation for mitigation is all a function of who's polluting most and who should be paying the bill most. So for doing that, they said the most important thing is, if you want to answer the question of who's polluting most, you need to know, you need to evaluate whether a country or a specific region is really polluting or not. So for that, you need to properly monitor and evaluate. So monitoring and evaluation becomes the core, crux of the problem on hand. So I have taken this as the crux, and we started working. This is where I'll slightly digress into our scientific work. We started working on this. We started working but a couple of years before this AGR, that is Adaptation Gap Report 2021 came, and we looked at the data. I'm just going to quickly share some of the data with you. Is my screen visible to all of you? Hello?
Yes, sir.
Okay. So what you can see is the same graph, but
we can't see any graph, just plain screen.
You can see only the plain screen, is it?
Yes, sir.
Okay. Is my screen visible?
Not.
Not, yeah, it is.
Yes. Now it is.
Yes.
Yeah, you can go ahead with the presentation, sir. It is visible.
Okay. Yeah. Is it still visible?
Yeah, it
Yes,
is
sir.
visible. It is visible.
Okay.
Yeah.
Now, if you look at the x-axis, it starts from year 1750. From year 1750, if you that's let's say about 100 years I have taken. The entire world's pollution is borne by European Union, United States, and Russia. So
Your voice is missing, Professor. Yeah.
is it visible?
It is. Your voice is now back. Yes. Slide
Yeah.
is very visible, and your voice also is now back. Yes.
Very good. Very good.
Yeah, we missed a few sentences. What you mentioned, little.
Okay. What I have done earlier is I was playing around with this interactive graph. I've slided my window from 1750. My connection seems to be slightly unstable. I've slided my window, the time window, from 1750 to 1850. And then I've shown you a graph where it shows that the world pollution was brought about by European Union and the Americas, where India was nowhere in sight. But if you forward it to 1900s, maybe about 1990, okay.
Yeah.
1990, now India's curve starts picking up.
Yes.
This is when we started believing in globalization, liberalization, P.V. Narasimha Rao's tenure. So what is the effect of that? Development and pollution are related. And if you take care of this graph, if you look at this graph from a different perception, what it means is although the China now has risen, has overtaken the world as United Nations in pollution, China was not responsible till a few years ago. So this is a different viewpoint. This is a different perception. So the entire gamut of the blame game on who should bear the expenses for mitigation is based on the crux of this simple theme that, look here, you have been polluting the world throughout the ages, and we have started polluting only at last 10 years or 20 years or 100 years together. So this is where the confusion starts. And it gets confounded by some of the things, like if you look at the map of right now, this map is an annual carbon dioxide emissions in 2020, which basically shows that China is the most pollutant nation, which accounting for about 10 and odd billion tons out of the 34 billion tons all over the world. And India is not far behind. India has about 2.4 billion tons out of the 34 billion tons. Nevertheless, America is still ahead of India in pollution. So this is where people start fighting with each other, saying that, look here, 100 years ago, we didn't have any pollution, and then you introduce fossil fuels to us. And why did you introduce fossil fuels to us? Is because you wanted to do commerce, and you wanted to boost up your economies. So to do that, we have taken in fossil fuels. We started developing all the technologies which were given by you, and then we went into this fossil fuel business and burning of fossil fuels, and that's how we started polluting. So in this entire process, who has benefited? The developed world has benefited. Why? Because they were able to sell the technology, which they started using it since centuries ago. So this entire gamut of this, I'm going back to Just bear with me till I figure out how to change my screen.
Yeah.
Is my screen visible now?
It is. Yes.
Okay. This is the whole crux of the debate which is going all around the world, and countries are fighting with each other that we don't want to sign on the dotted line, and because the blame game has started. So against this background, what we thought is we will do our bit by asking pertinent questions regarding the monitoring and evaluation, which I pointed out in my earlier slides. So if you look at how pollution is monitored all over the world, we have a number of sensors or technologies which are thrust upon us in the sense that in the nation, our nation, by developed countries, primarily USA, Europeans, Australians. If you look at this, the technologies, there are a number of sensors which are used, a number of systems which are used, which I have shown on the right-hand side of my screen, which are accepted standards, scientific standards. And each of these technologies measure one of the pollutants, like sulfur dioxide, you have a technology or a sensor or a system, nitrogen dioxide, and these are the pollutants. And particulate matter, PM2.5, PM10, PM1, ozone, lead, carbon monoxide, etc., etc. What we found out is the number of caveats associated with these measurements, and there are innumerous challenges associated with the measurements. There are differences in sensing characteristics of each of these, array of sensors, a spectrum of systems, brought out by different sources, different researchers, different companies. And there are biases across all the instruments and biases across stations. And integration of these disparate sensors in a single station becomes quite challenging. So at the end of this, the sum and substance of all these is the measurements are indicative, but not absolute. If you look at around pollution monitoring stations, Kerala has maybe about 10 pollution monitoring stations, primarily in Trivandrum, Kochi, Kozhikode, and other bigger areas, not in the smaller places. They look like something like this. There are big containers which host an array of sensors. So, and these are extremely expensive in nature. Each of these systems for pollution monitoring costs about 1.5 to 2 crores of rupees, depending on who is selling, who is buying.
Yeah.
If you understand my drift. So we have asked the question, is it right that are we really monitoring the actual pollution, or are we also monitoring the errors, inaccuracies already embedded in this pollution monitoring measurement techniques? So this is where we started looking at, and we posed ourselves challenges. We posed ourselves questions which to tackle these challenges. We said, can we come up with an in situ real-time remote detection? Most of these sensor systems which monitor pollution are not in situ. What it means is you need to suck air from somewhere else and drive the air or pump the air through a conduit to the system, and the system is stationed in a container. So it's not really an accurate way of measurements, and it's not real time, and it's not a remote detection because there's a lot of human intervention going on there, and then there is a material intervention. And then we asked also the question whether we can have a single system instead of so many systems, disparate systems floating around. And then we said, in addition to the conventional particulate matter 10 and particulate matter 2.5, can we also monitor microbes and bacteria? Because microbes and bacteria play havoc with our health, and COVID pandemic has enlightened us to this aspect. And then we said these are stations which are like white elephants, and they are huge, which require about 30 feet by 30 feet by 30 feet space. And can we have something which is portable? And the most important is, can we have something which is economical and compact? Why economical? Because on any of these systems cost, as I said, about 1.5 to 2 crores. So a city like Kochi will have maximum 1 or 2 stations. That's what the governments can effort. But if you look, and if these stations, generally, by and large, these stations are located in green zones. So what does the statistics show to the common man is everything is hunky-dory. If you look at, if you get down in the airport at Delhi, maybe before this year, every time I see everything is green, that is, everything is under control. And that's what's happening. So to avoid that, can we have something which is economical, but it's reliable? And then we also asked ourselves whether we can have a system which works both for indoors as well as outdoors, because we have seen the statistics which talks about indoor fatalities of 4.3 million deaths. Then the most important question which we asked ourselves is, most of these measurements, the systems it's something like a thermometer which we use, which is, we call it in the local, in our fluid dynamic jargon, it's a Eulerian measurement. What does it mean is you have to pop the thermometer into your mouth and it gives you a reading. The question we asked is, can we do a profile of the temperatures of the body? Is it possible? So that's what the Eulerian versus Lagrangian measurements. So lo and behold, we made enough breakthroughs with innovative technology, and that technology we called it as OHM, which basically is OHM has connotations in most of our the regular Indian connotation, but it also has it's an acronym which stands for Air Unique Quality Monitoring System. We are at a stage of TRL9, MRL9. What does it mean is there's a standard which is brought out by NASA. TRL is technology readiness level on a scale of 1 to 9. 9 is the highest, so that is the label. And manufacturing readiness level is on a scale of 1 to 9. Again, we are at MRL 9. What it means is this technology has been tested, evaluated, certified, and is ready for commercialization. Just to give you a brief background on how we have evolved these technologies, I did a project for the ADA, which is Aeronautical Development Agency, which was basically to monitor wind on the futuristic fighter aircraft. So that project where we have come up with the technology where we convinced ourselves and we convinced our peers that we have a optoelectronic or a photonic system which is capable of monitoring the environment. By environment, the temperature, pressure, density on a fast-moving fighter aircraft. This is going to be put on place in AMCA. AMCA is the future generation of Tejas fighter aircraft. During this process, Admiral Madhusudan was remarking about the wind tunnel, which we have already constructed. So I made a wind tunnel to do this testing, all this testing, rigorous testing. So we have come up with the technology called as Vayu. Tharani is the name of the technology which we have submitted. We have supplied to AMCA, that is ADA, Ministry of Defense. Tharani, you would be knowing that the Sanskrit name of Tharani means a ray of light. Vayu is Vayu, wind. And Samira is something which we have come up with under the technology, which basically looks at a laser light, pumps in through the air, will give you a temporal profile in space. So it's a spatio-temporal profiling. And then the final one, all these technologies some of these technologies have gone into the technology which I'm just discussing about, air pollution monitoring, called OHM. Now, whenever we say it's a system consists of a number of sub-technologies, and we have gone through this design and development process. We met a number of challenges, and we have been successful. I don't want to get into the details, but basically it contains control, engineering, signal processing, data acquisition, data analysis, signal conditioning, electronics, sensors, all the, not in nitty-gritty details, which basically what we have done is we have looked at science from a different perception. That's we changed our paradigm. We shifted, we made a paradigm shift in our perception of science, and that led to new technologies, led to engineering, subsystems, system, and then that's how OHM was born. This is what OHM looks like now. If you recall my earlier slides, I was showing you a big white elephant, which was 30 feet by 30 feet container. Now, this is 120 by 180 millimeters in size. This is portable, this is lightweight, and it doesn't cost crores of rupees. It's much, much, much cheaper. So this is a photonic system for real-time monitoring. I'll skip this slide because how we have attained this spatial profiling is by using some simple laws of physics. By putting a small lens in front of the laser system, so that the lens will make the light focus and defocus at different regions. So that is the whole basis for this. And this has resulted in the entire spatio-temporal profiling. And then what is the next step to be done is we need to test it, we need to evaluate it, and we need to calibration. So this we have done in association with Defectech UK, which is an international accreditation firm based in UK, but they have offices in Bombay. So we have done it there. And the entire principle of OHM is you pump in through this system, you pump in a light beam, which gets backscattered, and that backscattered thing, everything else is embedded in the small setup. Where there's a junction box, and then junction box will do some signal conditioning. It pushes data to a cloud server anywhere in the world. And on the cloud server, pertinent machine learning, deep learning algorithms reside, and all the big data analytics is done. And then the data, meaningful digestible information is pushed on to the mobile of a user. So this is the level of technology which we have acquired. So it requires, it has embedded scattering properties, machine learning, deep learning algorithms. And then what is the result of all this is we are in a position to instantaneously find out what are the pollutants, what are the quantity of the pollution. And this we have compared with imported systems and in a number of places. Especially in Karnataka, Bangalore also. And we have seen that our accuracies and sensitivities is we are in a position to monitor pollutants to the level of 1 part per billion, 1 ppb, or 1 microgram per cubic meter, which is an extremely sensitive measurement. And once we have done that, we got our accreditations, certifications done. And this entire data is, it gets into the domain of Internet of Things, array of things, so that the data is pushed immediately onto a cloud server. And from the cloud server, it goes to the command control center, wherever it is situated, anywhere in the world. And then from the command control center, the meaningful information is pushed on to the mobile of a user. So this is the level of technology which we have achieved indigenously. I'm just going to quickly show you, this is basically what a screenshot of the screen looks like, the dashboard looks like. This was taken from a live dashboard where you can see all these pollutants, and they get refreshed at whatever interval we desire. So you can see this values changing. And then we have built a number of statistics to that. We can look at statistics, we can look at the past records, we can also look at predictive analytics. If it's going to be, if this is the situation, what is going to be the pollution level tomorrow? Those kinds of questions can be answered. So against this background, so this again, I'm summing up. We have done calibrations, intercomparisons in wind tunnels. We have done in international laboratories, Effectec UK, and then we have compared with regular standard scientific equipment, and we did field intercomparisons with imported systems. After doing all this, we said we have come up with different versions for different applications. Our ruggedized version can withstand weather from -25 degrees to +70 degrees. So that is the hot sun or the cold snowy winter, either on the mountain or at sea level. And these are environment resistance. They can withstand harsh environments. They are IP65, 66, 69 grade systems. So what we have achieved by looking at a paradigm shift in our understanding of the pollution problem is an indigenous design development of a novel photonic system, which consists of a number of subsystems. I'm going to quickly, this is a video which basically talks about what are the capabilities in terms of spatial profiling. On the left-hand side, you see the regular mast, which is put if you want to do a wind profiling over a height. You have about 22 or 25 different sensors to look at a 100-meter profile. Whereas the system which we have developed, we can go with one simple, small, portable system. We can go up to maybe 300 meters or so. So for pollution monitoring, you require about 15 sensors with 200 square feet of space minimum. But look at our system, which is capable of monitoring all pollutants simultaneously at ppb levels, parts per billion level, simultaneously from a remote place. This is basically what it does. We just, throw a beam of light, it gets backscattered, and then this is all basic, everything is processed in between. And we are in a position to look at whether primary pollutants are there, secondary pollutants are there. What we have also accomplished recently is, apart from that, is we can do environment monitoring, whether we can do monitoring in air, water, and land, indoor as well as outdoor. In addition, what we have accomplished is we can even look at bacteria. So this is the bacteria. This is the exciting part. And we can look at, we are embarking on looking at, we have been successful. Recently, we completed our demonstrations in a biotechnology lab in VIT Vellore, Professor Arul and I, where we have been we got extremely exciting results. That we were able to distinguish and discriminate bacteria in a given air sample. Okay. Now we are progressing towards virus, but we are also hoping that we can do chemical as well as biological pollutants. Now these virus, chemical, biological pollutants have relevance to things like COVID, etc.
Yeah.
Okay. So this is what we can do. We can look at pollution and different applications. And I'm going to close this. We have been accorded recognition by various bodies, governmental bodies, and
जुड़ी आधुनिक टेक्नोलॉजी में ये बहुत मदद मिलेगी। इतना ही नहीं, ये इंडस्ट्री हम जो इंडस्ट्री 4.0 की बात करते हैं,
Even Prime Minister
इंडस्ट्री
has
4.0 के लिए भी
appreciated our efforts.
भारत की भूमिका को सशक्त करेगा। साथियों, आज का भारत पर्यावरण की दिशा में दुनिया का नेतृत्व करने की तरफ बढ़ रहा है, लेकिन एयर क्वालिटी और एमिशन को मापने की टेक्नोलॉजी से लेकर टूल्स तक हम दूसरों पर निर्भर रहे हैं। आज इसमें भी आत्मनिर्भरता के लिए हमने एक बड़ा कदम उठाया है। इससे भारत में प्रदूषण से निपटने के लिए ज्यादा सस्ते और प्रभावी सिस्टम तो विकसित ही होंगे, साथ में एयर क्वालिटी और एमिशन से जुड़ी टेक्नोलॉजी के ग्लोबल मार्केट में भी भारत की हिस्सेदारी बढ़ जाएगी।
And
हमारे
we had been, the Minister of Science and Technology, the former Minister of Science and Technology, did a number of tweets, Harshvardhan, number of tweets talking about our system and etc. etc. So.
वैज्ञानिकों के ही प्रयास से जुड़ी आधुनिक
I'm just, and we got a few awards in this process. It's not important, but these are the management lessons which I'm taking. I've built up some confidence after speaking, so I thought this is what we learned. What's good for goose may not always be good for gander. Systems which are imported, which are made by other countries, may not be suitable for us. And some of the naval officers now in the audience, both the revered admirals will vouch for that. A sonar which is good, made in USA or Europe, which does wonders in those waters, may not be always working in our waters. So, and the most important lesson which we have learned is the difference between possible and impossible lies in the determination, perseverance. And yet another important thing which I would like to share is knowledge and ability to solve complex technological problems are neither proprietary nor the prerogative of international institutes or developed countries. India can do wonders, and our youth are nowhere inferior or less than anybody else in the world. So the most important is if the government is ready to listen to people with good intentions, then we can always find good results. So these are the changing paradigms, and fortunately the present government has been supportive. And I would like to end with this slide and throw open the room for any questions if time permits.
Yeah, could we have the questions, Professor? Is it? Yeah. Right.
Yeah.
Okay. Prajit, please revert us back to the other mode. Yeah, right. Thank you, Professor. Thank you very much. Hearty congratulations for being part of the development and finding of this wonderful system, AUM. There are many questions that definitely, before anybody asks, I would like to get certain things clarified with you on this.
Yes.
We'll come to that. But before that, you have actually made some very pronounced statements like, in 1990, when Narasimha Rao opened India, India also opened for the pollution. And in the sense that development and pollution are interrelated. That's what you said once.
Yes.
And you also had said that, okay, all these huge, bulky, inaccurately measuring monitoring systems costing the crores and crores of rupees could be replaced or disrupted by some finer indigenous innovations.
Not inaccurately, but they need not be accurate.
Need not be accurately. Okay, fine. Now there's a distinct difference between accurately and need not be accurate. I take that point, sir. Okay, yeah. And also now coming to the individual obligation. Okay, now some quick questions that I would like to ask is, Professor. Okay, now yours is approved. This technology that you have actually come out with, is it fully approved by the governments of the world? Of course, because since I saw Modi ji speaking about OM, so it definitely there must be some level of a blessing that your organization must have received. But how is it being approved by research organizations and such accreditation organizations across the globe, sir?
It takes some time because any new technology, it has to go through the gamut of acceptance.
Okay.
Acceptance takes time. So we have to, and it's not science and technology alone which plays a vital role in the acceptance.
Yeah.
We need the government support, and we are on because this is related. If a system which can replace a 2 crore system by a 20 lakh or 25 lakh system, it has far-reaching implications for economies. So there'll be a number of players, fighting tooth and nail, and we are requesting the government for their support. Government, in its own wisdom, thought that they'll push it through this Atmanirbhar Bharat, channel, and we are doing a.
So tentatively, what's the time frame that you think that it can be commercially produced, Professor?
It's already been commercially produced. They are ready. If people are ready to buy, we can deliver it tomorrow.
Okay.
We have about 20 numbers in our stock right now.
How many sites it is currently working? You were saying about some sites in Karnataka and others. How many?
Karnataka was removed because that was only for evaluation, but West Bengal, we have 2 systems working. We have one in the center of Delhi, which is the Department of Science and Technology, Ministry of Science and Technology.
Okay.
That is one, it's one system is there right under the nose of Science Minister. So a couple of systems are placed. Now we are basically looking for a push towards commercialization.
Professor, we live in a world. We live in a world of life and death situation now. People are saying it is 2030. Somebody saying 2050. Somebody saying 2070. Okay, we are putting up these timelines, and we are also putting up certain obligations on our part. So, if what is invented by, or what is manufactured, to researched and invented by your system, it is simple, it is portable, it is carryable, it is accurate, it even go to PPB level as far as the fighting is concerned. And then you said that it can actually measure, it can find out the availability of bacteria. Then you say that, okay, it can go to the virus. So even it could, in the event of a biological warfare, the testing can be, the identification can be done. So it becomes very critical and integrated, very critical as far as our living in life is concerned. So if such is the case, I think the government and the research fraternity must be putting its focus on to see that it is approved and it is used across the country and possible the world. What's your take on this, Professor?
This is where there is a lot of gap between the lip and the cup, if you may. What Delhi talks in open and what the Babus do in reality, there's a lot of difference. We are making our noise in appropriate forums, and hopefully maybe in the coming couple of years, we should be able to push our commercialization drive.
But Professor, there is another component here. See, now it is essentially being produced as a finding of your company, Castle Research. Now, had it been part of the DRDO, had it been part of any nationally recognized laboratory, don't you think that the proliferation of this could have been higher, or do you think that it is not?
No, it is. Now we are pushing it through the Department of Science and Technology, which is a central government R&D establishment.
Okay.
Something like DRDO, but not DRDO, it's Science and Technology. So DST is the one which is pushing it, because we got a grant from DST, and DST is pushing it. They have showcased it in Dubai or Abu Dhabi, wherever recently there was some thing, and then they were showcasing in Delhi. But then there's a lot of mismatch in the comprehensions between the federal government as well as the state governments and the different arms of the federal government. The Ministry of Science and Technology is one, but the people who have to buy is Ministry of Environment.
Yep.
So that there is, so people are trying to figure out.
Yeah, I heard that. You said about the babus, so I understand that.
Yes,
okay.
yes.
So the less said about it, the better. Now, tell me, Professor. Now, when you really come into a global market scenario where we have this bulkier, larger, multinational manufactured systems across the world versus this one that has come out. So, what do you think about an immediate competition to your types of manufacturing or the equipment that is manufactured by you?
Immediate competition?
Yeah. Anybody else in the world also must be working on something like this? Portable, these parameters. Yeah.
Actually, we went to a couple of expos all over the world.
Yeah.
Europe we went.
Yes.
So one of the comments which I would like to share here is where we were there just before the COVID pandemic erupted.
Yeah.
We were in both China as well as Netherlands.
Yes.
The people in Netherlands felt that if we succeed, then most of the other established international players have to shut shop. So that is the perception which it has raised, and that actually creates a lot of bottlenecks for us because people will start fighting tooth and nail. That's the reason why we have taken the help of the government. We have been speaking to the Australian government. Somebody in Australia are interested. We have been speaking to the Canadians, and because of the pandemic, all this has gone for a toss. So we hope in the coming year, if everything settles down, we should be able to push some of the things.
Okay. Once again, hearty congratulations. So we would want to hear more about it in times to come as to the approval, global usage across the country, the ministry's recommendations, and of course, Atmanirbharta that we attain through this. Okay. Now, I have a question for you that is something, what do you think? You see, you have said this, so I'm just asking this question. Countries of the world are asking, you said that, okay, when America had been polluting the world, China was not doing it, but China is now doing it much bigger than America. Okay. Now, that is the same case with India. You have seen that 91 later, you have seen the graph going upwards. You have even animatedly showing the graph going upwards. Okay.
But something which we need to remind ourselves is, if you look at the per capita pollution,
yeah.
We are playing around with statistics. Per capita pollution, because we are in large numbers, the per capita pollution by an Indian, average Indian, is much, much less than an average American.
Okay. So that is to do with development and consumption, right?
Yes.
That is to do with the development and consumption, right?
Absolutely.
So that is why I want to ask you this person. What's your personal thinking? The highest polluter of the world should foot the bill, isn't it?
It's no longer that simple because the highest polluter is no longer the highest polluter.
That is right.
So we get into this nitty-gritty statistics saying that what is your per capita pollution level?
Yeah.
These are pointless debates. All of us know that pollution is bad, and it is bad not only for us, our health, our economy, but also for the future generations. If you look at the increasing number of cancers, I did a survey along with some of my doctor friends. The police beat constables who, traffic constables who are, exposed
out in the open areas.
Out in the open. The number of cancer cases amongst them is very high.
Yes.
And that's alarming. And frankly, they don't have that much of knowledge, and comprehension that they are being exposed because of pollution. And so before anything reaches a tipping point, we need to, pull our socks together and without any blame game, what can be done? What can be done is more and more greener energies.
Sir, as far as global warming is concerned, how far are we from the tipping point? How many years are we from the tipping point?
Well, it depends on which model you believe.
Mhm.
That's again debatable. If you put two scientists in a room, they'll be fighting with each other for 20 years.
Okay.
So, but we have reached a stage.
Yeah.
If you look at the statistics, we have reached a stage. We have reached a stage where 1.5 degrees of
Temperature.
increase in temperature,
Yeah.
which is almost close to the tipping point. So it may be about 10 years or so.
10 years
So-
or so.
So if we really go into the 2-degree, which is what all the countries are fighting about, then a lot of things like sea level rises, all these unseasonal
Inundation,
things,
yes.
inundation, droughts,
Yep.
and probably there'll be a situation where Kerala will not receive any monsoon.
That's right. No, by
Yes.
the half of Kerala would have been underwater by the next day.
Yeah.
Okay,
So-
Professor, now see the global consensus is a major problem. Even in Glasgow, if you look at it, China, Russia, Brazil, and some of the other nations did not participate. Some of them participated because their leaders could not participate. But China, Russia, and Brazil did not participate purposely. I mean, if these sort of incongruencies in the global understanding, these tipping points are really reachable. Such alarming pace, is it? Alarming pace.
Absolutely, absolutely. You're right on dot. See, some of the things is we know for sure that development and pollution are juxtaposed.
Yes.
So either we need to take a call. Are we prepared? Like, am I prepared to leave my car, walk to the office?
Mhm.
I'm not.
Yes, we are not.
Frankly.
And single car drivers, we don't share it.
Yeah. Yeah. And switch on the lights. All these. So it requires cumulative efforts by everyone, and most of the concentration is based on larger populated countries like China and India.
Yeah.
And I personally feel that we are more reasonable to reason. We listen to reason much more than a developed nation. Like if you look at the statistics of vaccine population in India, we don't ask questions why we should get a vaccination. Take the developed countries where the vaccination rates are abysmally low. So maybe we should there should be some drive. Maybe we should go back to, if you may, Sanatana Dharma's principles, saying that leave everything. And so some kind of a drastic paradigm, again, I keep using that word, paradigm shift in our perception should occur. Yeah.
Thank you, sir. We are almost coming to a close, and before I close, I have two comments that I've received on the chat from the people. One is from Suresh Kumar TK. He says, are there R&D organizations in the private sector in India in developing portable economical compact monitoring equipments, and if so, how much the government support for this? Mr. Suresh Kumar, this has been answered. In fact, what he had shown is a private organization that has developed this, and he also told you about the grant that they have received from DST, and also the communication that Prime Minister Narendra Modi said about OM. So that actually answers your question. So I'm not going to Professor for an answer here. Next is Bala ABK, Balakrishnan asking, sir, is it interesting to know that OM measurement methodologies can give precise data on which element or compound polluting our air? Do you recommend controlled measures also? Can you answer this, sir?
Can you repeat that?
I'll repeat it, sir. It is interesting to know that OM measurement methodologies can give precise data on which element or which compound is polluting our air. Okay, so the detection is possible.
Yeah,
do you recommend control measures also? How can this be controlled? Once you measure, you can control. So how can this be controlled is a question Bala is asking.
One of the things we can do is we can also ascertain who is polluting. Let's say you have a region where you have 20 industries. It's possible to pinpoint which industry is polluting. Then leave it to the authorities to take care of whatever action they want to take. Other control measures, there are already control measures in place, but most of the people do not follow because it costs money. And they work hand in glove with the CPCB, which is Center's Pollution Control Board. And corruption is one of the factors which is taking us back. Yeah.
Very sad. Very sad.
But this can become a sort of a regulatory mechanism where once you know who is polluting, what he is polluting, how much he is polluting, so appropriate authority can act
accordingly. Professor Rao Tatavarti, it was indeed a completely different level of learning that we have had today. Insofar, we have been going around management methodologies and management methods and HR and finance and accounts and things like that. So
I hope that
of course, if you really look at it, we had about 60 people who had been completely glued to your presentation till the end of it. So that very clearly shows that people had been interested in watching your professors. Thank you so very much for giving this perspective. And as you rightly said about the paradigm, you started defining paradigm by Thomas Kuhn and then went ahead with that. It was an eye-opener session as well in terms of each countries and the possibilities that we can come across in measuring and monitoring, measuring and controlling the pollution, and thereby bringing the global temperature down, or the methane gas and CO2, etc. down. Thank you so very much. I would now hand this back to the chairman of the session, Nirmala, to conclude it. Of course, there will be a formal vote of thanks later, but definitely I want to thank you from the bottom of the heart because you have been so cooperative and you have just brought in a fresher breath of air as far as our understanding about air pollution, global warming, etc. is concerned. Nirmala, back to you.
Yeah, thank you, Mr. Nair. Thank you, sir. It was overall indeed far beyond our expectation. Appreciation from Prime Minister, recognition and award. Congratulations. Indeed, it is indeed a great privilege to listen to you, Professor. And Mr. S.R. Nair also asked the right question, and Professor rightly said right on dot, so that we could get more knowledge from you. And the videos what you showed about the pollution and the multiple sensor were very informative and knowledgeable. And there are a lot of studies and research. It is very interesting. And then certain figures are really scary. Then you are also mentioning about the indoor air pollution. It is really scary. Then he mentioned about how we can monitor, evaluate the pollution. And when he was just mentioning about China is the most polluted nation and India is not far behind. And Mr. Lava, one of our members, was mentioning in the chat, China is making Apple phones for the world. Pollution is just shifted from USA to China. Very interesting.
Exactly.
Yes. And we also learned many management lessons from your presentation. One is, if I mentioned, the difference between the possible and impossible lies in the determination. And as you mentioned rightly, let's make a better nation for the future generations. With this, thank you very much. And I would like to request our Vice President, Mr. A. Balakrishnan, to make propose a vote of thanks. And Mr. Balakrishnan is the Executive Director of Geoth Financial Services Limited. Over to you, Mr. Balakrishnan.
Thank you, Senior Vice President, respected guest, Professor Rao Tatavarti, and our Mr. S.R. Nair, our Program Committee Chair, past presidents, members of KMA, students, and friends. It was a great presentation. Please let me tell you that after so many years, I attended a science, physics, computer science, and statistics class. Very interesting presentation. And in fact, I noted some URLs which was there in the presentation. I definitely go through all those things. There is, we all are actually managers. Most of us are managers. We have a given target of optimization. What we are actually doing is try to optimize maximum, increase our production, and if it is fossil fuel, whatever it is, no one is actually taking, even a generator, all those things, everything. So we are on a cost arbitrage and labor arbitrage business. So in this particular era, your contribution to the entire world is significant and extremely valuable. and everyone is now talking about green growth. I am sure that in due course of time, people will understand the value of your work as well as the sustainable growth. Thank you very much, sir, for your insight and the presentation you made. And it is a great presentation. And thank you, sir, for extracting and the additional input from him by putting right questions. Of course, we need to understand more. This is a really scientific topic. I think we need an elaborate discussion on this particular topic, on especially air pollution. The data is alarming. Even COVID death is clocking at 5 million. You are talking about 9 million deaths because of air pollution, and that means actually COVID is much lesser problem when compared to the air pollution. So thank you all.
Well,
thank you.
One of the statistics which a recent Harvard study has pointed out is if there is an increase in pollution by 1 ppb, 1 part per billion, there will be a 15% higher fatality when it comes to COVID.
Wow.
Oh,
How linked are all these things, Bala?
right,
It's a small world, all linked up together.
right. And thank you, past presidents, members of KMA, students, for attending this wonderful seminar. Thank you all. Thanks a lot.
Thank you all. I see my good friend Rajshekhar there.
Yeah, I was actually, yeah, there is.
Yeah. So,
Nirmala?
Prijit, I think, sir, kindly
Yeah,
accept,
moment. Right.
kindly accept our
Professor, this is a physical memento that you had actually been, you delivered this is a physical memento. Your photo is taken across. So that way it is as a sort of real time. This will personally reach you at Vizag in about 2 weeks' time by a courier.
Without
so
polluting, without much of a pollution.
So kind of you. Thank you, everyone. And it's
thank you
been a
very much,
privilege to speak to all of you.
Yeah.
It's my real pleasure and privilege.
So good, sir.
Thank you all. Thank you,
It is
man.
our honor and privilege, sir. Thank you very much. And I request all members to kindly note the next program, CSR Award, CSR Summit, is on 17th December. Kindly make a note of it. And looking forward to meeting all of you. And thank you once again.